Hi everyone. I've had a couple of students asking me some questions about some problems, and so I wanted to do a live demonstration, just keeping it nice and short so it hopefully uploads in time. Just wanted to give a little face-to-face. I hope you're doing well. I hope you're keeping busy and working hard and relaxing and trying to make a schedule for yourself. I know it's hard to do. Please feel free to reach out if you need help with anything. All right, let's turn this around here. So the first question I keep getting from students is number 35. Okay, and I notice here on the left side it's all secants and it wants to get turned into tangents. So let's just walk you through the correct process. You want to say left hand side equals, and we're going to work with the left hand side. Don't even look at the right hand side. Okay, this right here is the answer that I want to turn things into. Tangents. Okay, so I can't have secants, only tangents. Okay, this is the first Pythagorean identity, and if we go ahead and divide everything by sine squared, you get 1. Divide him by sine squared, you get cotangent squared. Divide by sine squared, you get cosecant squared. Okay, so that's the second Pythagorean identity. Let's do it again, this time dividing by cosine squared. That makes tangent squared. Divide him by cosine squared, you get 1. Divide him by cosine squared, you get secant squared. Okay, and I can't help but notice that this problem has a lot of secants that need to get turned into tangents. So I'm going to use this third Pythagorean identity. Let's go ahead and factor out secant squared. And that leaves us with secant squared minus 1. Okay, I'm going to put parentheses around each of these terms, and we're going to go ahead and replace them. So secant squared can get replaced with tangent squared of theta. Perfect, using this identity right here. Now what about this? Should I leave secant squareds in the problem? I don't think so. Okay, so I'm going to put parentheses right here. Secant squared, I'm sorry, this needs to have a plus 1, right? Secant squared minus 1, if I move the 1 over, leaves us with tangent squared. Okay, perfect, nothing but tangents. Okay, make sure you have parentheses around this quantity. We're going to go ahead and distribute it in, and that gives us tangent to the fourth of theta plus tangent squared of theta, which is the right-hand side. Done. Okay, so this one needed factoring, and it also needed identities. Okay, identities. I noticed that the answer did not have fractions, so I don't want to make fractions here. Okay, I want to make tangents. Use that answer to guide you. The next one people were asking me about a lot is number 43. Okay, and I'm just going to say right here that this is the trick, and I know this trick gets taught in one of the next couple lessons. Okay, so I'm going to take the left-hand side right here, and I want to make it be a fraction, but it is a fraction. I want it to have a plus sign on top, and it does, and a minus sign on the bottom. Okay, I saw a lot of you that had work. You were trying really hard by changing the sines and cosines and making common denominators here. Okay, so what I'm going to do here is take the problem just the way it is, and I'm going to divide each of the terms. Okay, so I'm going to divide the first one here by tangent of v. And if I do that to the first term, I need to do that to the second term. Why am I dividing by tangent of v? That's going to turn this second term into a 1. But if you divide the top by tangent, you have to divide the bottom by tangent of v. And what that's going to leave us with is, make sure you use equal signs. 1 divided by tangent is cotangent. This is going to be a 1. Here we have cotangent of v minus a 1. Perfect. Done. I hope you're doing well.